Hi everyone, I'm Johnny DeBlasi. I'm an artist and professor of digital media and scientific visualization. And I'm going to start off by briefly introducing the panel and its themes and then jump into my presentation. My colleagues and I came together to form this panel in order to look at artificial intelligence uses in creative practice and what they reveal about themes of agency and autonomy. How are AI-based tools and methods such as machine learning and deep learning, evolutionary computing, and agent-based approaches currently being utilized by artists? And what kinds of novel experiences are possible at the intersection of machine agencies and those of non-human organisms? And finally, what theoretical frameworks and methodologies can be utilized to properly analyze and evaluate this work? So in my presentation on the panel today, I'm going to start off by talking about generative machine learning models and sort of touch on the more recent history of this technology, which will then lead me into present and discuss a current project I'm working on right now called 432 Hertz. So 5 years ago, Google published an article about a technique they were developing called inceptionism, where the engineers were trying to understand, quote, what exactly goes on at each layer within a neural network. They wanted to understand what was really going on inside the neural net, specifically to understand why and how it works, and what are the properties that drive a model to be a success or a failure. As they were taking this closer look, the engineers came to, quote, one surprise: neural networks that were trained to discriminate between different kinds of images have quite a bit of the information needed to generate images too, end quote. So the engineers aptly, I think, named this new technology Deep Dream. And this was one of the first of many technologies to advance that is now able to generate novel output. So rather than having machine learning models that were used to discriminate, now they're creating models that can generate novel imagery in this case. For example, the slide here is one of the images that was generated by Deep Dream. And so now, of course, there are many other models and uses where the machine learning technologies are generating novel music scores or novel bodies of text. And so this raises issues of thinking about the machine as a creative agent. So this idea of the machine as creator is not necessarily new, and we could go back and look at the history of computational media in the arts and technology in the arts and find lots of examples, but this is the first time artificial intelligence is being used to simulate the creative act. And we could think of this also as an extension of the ongoing debate about, authorship and creativity. And my colleagues are going to address these issues as well in this panel. But for me, what's interesting is exploring how to use this technology within my own creative practice. In her book on thought, Catherine Hales proposes a couple of binaries in order to contextualize her analysis of non-conscious cognition, cognizers and non-cognizers. And later she proposes the distinction actors and agents as terms to also kind of think about these two groups. During this argument, she points out how technical systems and computational systems are cognizers, are within that group. And furthermore, we're seeing that these computational systems are gaining more and more autonomy as we've seen them being deployed in various industries around the globe. In addition, she states, quote, "The capabilities that cognition bestows, flexibility, adaptability, evolvability, imply that cognizers have special roles to play in our evolving planetary ecologies." Finally, this framework sets up the possibility that cognitive technologies may perform as ethical actors in the assemblages they form with biological life forms, including humans, end quote. She also talks about how computational media have a distinct advantage over other technologies and how they're not necessarily the most important technologies or the most transformative, but that they are distinct, and that's because they have this stronger evolutionary potential than other technologies. I'm bringing this up because it nicely frames the way of thinking about these generative machines in relation to their agency and autonomy, and to think of them as non-conscious cognizers or actors. And this will serve as a good introduction to my project, which is an exploration of an interaction between these creative machines and human artists. So this brings me to a project I'm working on currently called 432 Hertz. And with this project, I wanted to take this generative technology and utilize it within my own artistic production. And what I'm doing essentially is building a generative artificial neural network. And the reason why I'm showing you this slide here of code is that at its core, a neural network is essentially a whole bunch of matrix math, which I think is really interesting, but I won't get too in depth on that. But I'll go ahead and play a few clips now of the project. So with this project, I really wanted to explore AI and this generative neural network as the aesthetic output in and of itself. So rather than having the AI solely create something for me, I wanted there to be a conversation between myself, the performer, and the AI. And so I'm also interested in this idea of the performer and simultaneously the trainer of this net that's outputting this evolving aesthetic experience of sound and imagery. And that concludes my presentation. Thank you.
Okay, hi. My name is Carlos Castellanos, and I'm going to be talking about the intersection of living and machine agencies in the arts. So I'll be looking at sort of a particular range of artworks that feature encounters or interactions between living organisms and intelligent machines, often computational systems employing machine learning methods. So let me start off. Well, so I'm going to argue for the recognition of a distinct aesthetic paradigm with these kinds of works, right? Rooted in the unique ways that non-human organisms and intelligent machines evolve their behaviors in response to one another, right? So sometimes this type of work falls under eco art or bio art, but I think, like I said, there's somewhere maybe in between a kind of unique sort of paradigm that there isn't like really a framework to discuss it. So I'll try to outline a few points in the next 7 or 8 minutes. But let me talk about the slide I had at the beginning, just to give maybe a little like historical context. So this piece is called Seek, and it was exhibited in, I believe it was at the MIT Media Lab. It's by Nicholas Negroponte, who is or was the head of the Media Lab. So there it was a plexiglass case with a computer-controlled environment full of small blocks inhabited by gerbils. And basically, the gerbils move the blocks, and the machine, the computer, tries to sort of rearrange them in a way perhaps that the gerbils, trying to anticipate how to help the gerbils with their task, I guess, right? But the designers didn't really sort of anticipate the reactions of the gerbils, who often, I don't know if they outwitted the computer or whatever. They just created, like chaos, disarray, right? And I think that's because there was some assumptions about the agency and autonomy, or lack thereof, of these non-human organisms, right? So there's nothing particularly new necessarily about sort of machines and non-humans sort of collaborating, let's say. But I think this is the first time, or certainly one of the very first times, that it was talked about or done in an arts context. So, as I said, there's no really established theoretical or analytical framework for artworks that feature these encounters. You might call it biocybernetic art or something, right? So that's, like I said, what I want to talk about. So just to give a few examples of these works, the piece on the left, CMD by Michael Sedbon. So he's got algae or photosynthetic cyanobacteria in these bioreactors, and they can claim access to light. So they need light, they're photosynthetic, and earn credits for their oxygen. So they buy the light with their oxygen production. They sell it in a market, and the market is simulated in software using genetic algorithms. That's what the sort of computer system is in the center. Sorry, I'm looking at my monitor here, but it's this thing here. So the AI system is, like I said, based on genetic algorithms, and is testing these different kind of financial systems on the bacteria. Autoinducer PH1 by Andy Gracie. This uses a basically there's bacteria here in these azolas, and they're interacting with real bacteria, or sorry, simulated bacteria, and they influence each other. So the digitized stimuli by the real bacteria cultures are interpreted by the AI, which then in turn dictates the supply of air, heat, etc., provided to the bacterial cultures, which are in the back here, and then that affects the planning of these azolas and the bacteria there. So it's just, again, this kind of complex relationship. And on the bottom, Omegas by Chaine1. These are leafcutter ants and their stridulation. They rub their legs together. That's tracked with sensors and with computer vision and mapped to the movements of the record player. Okay, so we can think about sort of what's important here. I think it's 4 elements, but I've sort of put them in pairs: agency and autonomy, and adaptation and emergence, right? And I think if we look at these, they sort of help us, develop, a framework that sort of accounts for what I see as a unique ontological vision that points us toward perhaps a new kind of art science. So we can think of agency, the ability to act in the world, is innately bound up with autonomy, right? And if you look at it in sort of out of poetic theory, autonomy essentially refers to the ability to have operational closure. which gives a living organism its autonomy. And that refers, what Varela says is the ability to organism to assert itself and bring forth a world for itself. Right? So I think these works give us a view of intelligent machine biological systems as a kind of performance of agency and a kind of exerting of that autonomy, right? Autonomy as a performance of agency. It's not a lot of time to read all this, so I'll, you can pause the video and read the rest of the text. Adaptation and emergence. This is where we have a change in internal structure to better perform in an environment, right? And that's adaptation. That's bound up with emergence. And Chaine1, who uses a kind of a cybernetic systems biology model, he defines emergence or an emergent event as one that occurs when an observer's model breaks down. So this neo-cybernetic model of emergence is observer dependent, right? So there's a subjective angle to it. And it's tied to our knowledge of the material and physical system, right? And therefore it's incomplete, right? So why these four areas, right? I think if we can apprehend and leverage this sort of that incomplete knowledge, that these things are exceedingly complex, as Stefan Beer says, we can understand interaction as experiments, as a dance of agency, which is what Andrew Pickering calls it. And then we can sort of understand alterity relations understand it as alterity relations, as this window into the otherness of these machines, of these organisms. So we learn through interaction as experiment, like I said, which is usually not something you do in science. You don't interact with what you're experimenting with. And I'll just give an example how this looks like in science itself. Gordon Pass's electrochemical experiments, and Stafford Beer using euglena to create what's called a euglena homeostat. And as there's not a lot of time to go into it, so I'll let you maybe look up the references. But I think as Andrew Pickering says, we can construct a canon of contemporary art that draws on science and technology as its substrate, but in its products radically subverts the ontological premises of modern science and engineering. And I'll just leave the rest for discussion, of how this kind of performance of agency and adaptation and emergence, as I see as the key factors, come into this kind of new sort of art science. And thanks.
Hello, this is Eunsu Kang. Thank you for having me in this awesome panel discussing important questions for our society and art at this point. My title is Sentient Beings, Responsible Human Agents, and Creative Machines, in which I present what I believe is where we should head toward, and thankfully where some efforts are being made. A general AI that would fix all our problems or would destroy all our lives does not exist. The current proliferation of AI technologies using machine learning methods may come from the fact that each algorithm is developed for a specific task and situation. This is the diversity that makes this field collectively powerful. However, there is a steep learning curve to understanding each of these algorithms. To properly apply them as a user, to co-create with them as an artist working with machine learning methods, or to appropriately bring these algorithms into our lives as a member of our society, the role of humans to ask questions and seek sensible actions in every step of AI development and consumption has become vastly important. In this talk, which should be less than 8 minutes, I'll quickly go over some research that I have been doing with my collaborators. First, what is the range of human roles in collaboration with machine surrogates? The human roles in co-creation with machine learning algorithms range between the role of the author and the audience. In between, there are positions as the user and as the moderator based on their tasks they undertake. Artists, as human agents, may engage in one or multiple phases throughout the spectrum. The current relationship between human artists and machine learning algorithms is considered to be mediated through technical artifacts such as algorithms and data, and thus the collaboration happens between human agents and their machinic surrogates. This image was sold for nearly $500,000 at the Christie auctions. The human agents in the development of this piece is rather a big group, from the Ian Goodfellow's team and Christie's curatorial team. As you can see in this example, this complexity of human agents' positions may cause a controversial authorship and ownership issues. Let's see more examples to look at the details of the relationship between humans and machines as creators. First, the Oral Fauna project is an interactive installation premiered in 2019. Oral fauna are unknown organisms imagined by AI. Human visitors may wake them up and share empathetic moments by touching or singing to them. Our algorithm, ADD and PDD, generated the unique forms that became oral fauna entities' bodies. Their voices were generated using Chris Donahue's WaveGAN algorithm.
Hello? Who are you?
The Oral Fauna also collaborated with a human guitarist, Donald Craig, for a duet for human and machine-generated creatures. The other example is a robot painting practice. We aim to make a creative robot artist that has its own artistic style and that is not merely a printer for reproducing processed or generated images. One team is working on developing an algorithm, and the other team has been working on experimenting with robot arms and a 3D motion capture device to help the robot learn from a human artist. This work integrates an artistic style to the brush strokes and the painting process through collaboration with a human artist. In a preliminary study, 71% of human evaluators found our reconstructed brush strokes are similar to the characteristics of the artist's style. Moreover, 58% of participants could not distinguish a painting made by our method from visually similar paintings created by human artists. This research will be presented at the Roman 2020 conference. Creative ML algorithms learn from datasets. As widely known, datasets gathered to test the machine learning algorithms may not accurately reflect our world. Zizo is an online tool that collects people's face photos and labels. Participants may choose their way of contributing and provide accurate description of themselves from their own perspectives. This slow and self-identified method is presented as an alternative to the currently available image dataset collection systems and as a way to mitigate harmful biases in machine learning applications. As one of many steps we would need to take to be responsible human agents working with creative machines. The title Zizo came from the expression junk in, junk out. What creative machines would do is closely connected to what we do and how we live, similar to children learning from their parents. We as human agents need not only to be sensible, but also to be responsible in our actions. At the same time, our efforts of developing and understanding creative AIs give us insights for reforming or advancing our society for the better future. Please feel free to contact me for questions and suggestions. Also, recently we launched Women Plus Art AI Collective. Anyone interested in it, please let me know. Thank you. Bye-bye.
Hello everyone, I'm Fabrizio Potronieri and I am the co-director of the Creative AI Lab and the Creative AI Research Group at the De Montfort University in Leicester, UK. And what I'm going to talk a little bit about here, it's what we understand as creative AI and what we are doing in terms of research with robots and creative AI. So for us, human-centered creative AI, that is the kind of AI that we work with, it's all about the design, development, and deployment of intelligent systems that cooperate with humans in real time in a deep and meaningful way. And it's defined by two main goals. The first one is that the creative AI system must continually improve by learning from humans, while B, that is the second aim, creating an effective and fulfilling human-robot interaction experience. So at the center of this discussion is the articulation of a shift in thinking of what constitutes creative AI and new human-centered AI forms of machine learning from inside the flow of the shared experience between robots and humans. We have been developing projects that search for new ways of working artistically with machine learning in real time, having the human artist in the loop with robots that sense constantly the environment and respond to it, also in real time, challenging and enhancing human creativity by stimulating, inspiring, interacting, and cooperating in the flow of embodied live art making, responding to the interaction with a human through a cyclical relational process. Creative AI, in this view, includes practices that have AI embedded into the process of creation, but also encompasses novel AI approaches in the realization and experience of such work. So the ultimate goal of these projects is not to find solutions to replace human creativity, but to enhance it and move it forward into new discoveries. So Amigoid, that's one of our projects, the one that I'm going to talk a little bit more here, is a robot which searches for humans to engage in friendship with. Two versions have been developed so far using different AI approaches. The first one, built in 2010, 2011, uses GoFi, good old-fashioned artificial intelligence, whereas version 2 that we started to develop in 2019 was built using a mix of GoFi and deep learning, take advantage of modern machine learning frameworks, which allow the use of computer vision and image recognition techniques in real time. The robot interacts with people through movements, lights, synthesized voice, and demonstrations of digital feelings, which in this case are very simple, with Amigoid reaction through its lights when the infrared sensor readings in version 1 or computer vision analysis of the camera video stream in version 2 indicate whether a human interaction gets close to it or not after a round of interaction. Once it finds a human, it starts to follow its potential friend, intending to start an endless friendship. It gets closer to the eminent friend and poses the question, Fabian, do you want to be my friend? Fabian, it's an imaginary friend programmed into the robot's mind. After the initial contact, Amigoid tries to conquer the friend through a series of phrases such as, Fabian, what do you search in a friendship? Fabian, fancy a pint, and so forth and so on. Amigoid can be described as a rational agent that acts so to achieve the best outcome or the best expected outcome. Hence, amigoid is a rational agent whose best expected outcome is to establish contact with humans and conquer their friendship. The concept of rational agent is pivotal to this project because it leaves room for the unexpected. The aim of a rational agent is not to achieve perfect rationality, as it is impossible in complicated environments. And also, any sensory system cannot provide perfectly reliable information about the environment. And the cheap infrared sensor in version 1 and version 2's camera are not exception to this rule. In both versions of Amigoid, all reasoning and planning are handled by classic GoFi logic. Although it appears simple, Amigoid's environment is sophisticated and high complex, as it involves processing human actions in real time and in unpredictable ways. What Amigoid does is to try to act in an appropriate way, even when there is not enough time to carry out all the computations and reasoning required to achieve the best possible outcome, a concept known as limited rationality in the field of AI. For version 1, a special room was designed where up to 10 people could interact with it at the same time. The engagement with human was made via a random selection process based on the analysis of data from the environment provided by the infrared sensor on the top of the robot. At the core of Amigoid 1 was an Arduino that controlled a DC motor, a set of lights, an audio interface shield connected to an amplifier, and two sensors, the aforementioned infrared sensor and a color sensor on the bottom of the plastic body facing the floor. The color sensor was used to identify the black border that surrounded the robot's circular room, delimiting the robot's range. This black border was necessary due to the fact that no two computer vision systems were used in this version, and it was impossible to distinguish between humans and wolves with the simple data supplied by the infrared sensor. Restricted to its partially observable environment, since its inaccurate sensor was unable to cover all the perimeter, version 1 had to follow a strict set of rules to have some sort of autonomy and learn something from what it perceived. The environment was designed to be as deterministic as possible, even if it was not a fully observable one, to try to avoid any kind of stochastic process, meaning that all future actions performed by the robot were determined by the environment's current state. Although it was a huge success, Amigoid's first version had several limitations related to the technological choice employed in its construction. These technological constraints had a negative impact on the way version 1 behaved and the level of interaction with humans it was capable of. It was a simple reflex agent acting on the basis of its current percept, which informed the series of condition action rules that handle its behavior. The major limitations of this approach, however, started to show when we tried to improve many of Amigoid's basic capabilities, such as its environmental sensing, and to implement new features like the ability to perform in any environment, not only in a special room. These problems were hard to be defined by a list of formal hard-coded rules. The fact that Arduinos use C language did not help either, generating a hard-to-follow and to-debug code with endless if-then-else structures. In the end, these questions proved to be not only technical but philosophical ones related to the approach used to design the robot. The attempt to use high-level symbolic, human-readable representations of problems was not flexible enough to provide the level of versatility needed. GoFi was holding the development back, and it took us a long time to realize that. Having worked with deep learning in different artist contexts in the last few years, we decided to give Amiguage another shot after getting a NVIDIA Jetson Nano, which could replace not only the Arduino used in the original design, but also the MP3 module that was used to play the pre-recorded voice in the first version. Despite our criticism about machine learning and deep learning, it's undeniable that many problems found in GoFi, especially the ones concerning computer vision and speech recognition, are much easier to solve using neural networks, mainly because they bring a different mindset, a distinct philosophical approach, apart from, of course, the technological innovations. That is beneficial to the field of creative AI, notably when mixed with GoFi techniques. Despite its limitations, by gathering and analyzing knowledge from experience, machine learning algorithms do not require human operators to formally specify all the knowledge that the computer needs, as opposed to the GoFi descriptive paradigm. Thus, it was easy to use an off-the-shelf algorithm to identify people and walls in any environment in Amiguai 2, making a special room for the robot unnecessary. Version 2 employs a cheap Raspberry Pi camera, replacing both the infrared and the color sensors. It was feasible to have the version 2 working in less than 1 week, including the port of the original C code to Python. The level of flexibility provided by this new setup allowed version 2 to keep track of the part of the environment it cannot see through the use of an internal state reflecting the unobserved aspects of the current state, making it a model-based reflex agent rather than its previous simple reflex agent condition. In terms of its inner logic, the new outputs originated from the deep learning algorithms fed into a simplified GoFi structure, which is similar to the one deployed in version 1. Well, and to conclude, this is just like a taste of what we have been doing in our lab, that is basically trying to find new ways to work with human creativity and deep learning in a meaningful way.
Hello everyone, my name's Lee Smith. I'm a senior audio research engineer at Lander Audio, and I wanted to speak to you about some experiences I've had working on creating music composition and production systems using artificial intelligence. So there's a long history to this, of course, dating back literally from the 10th century onwards. And what we can look at, if you look at this sort of list, and I refer to Charles Ames's article, that there's a long history here of musicians and composers thinking about how to formalize their compositional process. And we can sort of see a progression from rule-based systems to statistical processes that we see with Xenakis, through to machine learning, and ultimately, for instance, in 2019 in neural network models. My particular interest is in commercial music systems, and so these are systems which are built for to meet the needs of a product, for meeting the needs of musical consumers or producers. So, so the first thing that occurs if we think about these is that there's no really clear defined barrier or boundary between consumption of music and production of music in many of these systems. And so there's a goal here to reduce the barrier to entry for users. So for example, people who are engaging with music and using music, but perhaps are not necessarily musicians themselves, or we're talking about musicians that, for instance, are in their educational process. And finally, that can also play into audio engineering or music production, that they may not have the expertise in that sort of specialized area. So that's the first distinction we can make between composition and production. And of course, that draws on two different domains of traditional music theory versus audio engineering. Now, there's another characteristic of commercial systems is there's multiple popular music idioms that may well be needed or required, and so there's this question of how general a system needs to be versus how genre specific it may be. But ultimately, all of these things, you know, arise as a sort of a cultural artifact of the contemporary creative demands when they're produced. So there's also no real clear distinction between recommendation and of music, particularly given the amount of available musical data on the web now, versus generating music. So it can often be a smooth continuum between those two points. Both of those draw on this research discipline of music information retrieval. And so I'll give a couple of examples of those systems I've worked on. One is Enio, which was a system for music production for video to produce music which is matching against video, for instance, television commercials. And so in this case, the visual rhythm, which was derived by a visual model, was co-aligned with an audio system, so an audio signal. So in other words, there's a correlation between the rhythmic structure of the vision against the rhythmic structure of the audio, and that was using a rule-based system and DSP to produce the features that could match. A more recent system was HumTap, which was a musical social media application where users recorded a separate melody by singing into their phone and another user tapping into their phone. And these would be transcribed, and a unique piece of music of combination of these two pieces of music would be produced. So it was a means to sonify the social interaction between two users on the web. In terms of music production, Lander Audio produced a system for automated mastering. And so mastering is the signal processing of an audio, of a piece of music after it's been mixed in order to get the best sound from it for distribution. And so that's traditionally required human endeavor and time, studio environments and so forth. And so this is a model which uses machine learning. And what that provides is a drag and drop interface with very few parameters where the musician can upload their track and preview it and get ultimately a better sounding master. And then that's driven by, since mastering is actually genre specific, it requires a degree to which we understand what that genre of the music is, and therefore what's the most appropriate audio signal processing to provide. More recently, Lander has done a system for Selector, which is a sample recommendation system. So samples are small audio fragments or loops that many modern musicians use for creating music. And so in this case, we can use a content-to-content recommendation system. So given one loop, find other loops which are either acoustically similar or acoustically complementary to this first loop. And that's drawing on timbral, rhythm, and tonal characteristics in order to compute some sort of multi-dimensional distance between in feature space to derive which loops are close to one another, for example. So all of these are actually have some common challenges here, which I wanted to sort of highlight. And a principle here is of these design goals, which, as I mentioned, the complexity of the user interface often drives the reason towards using AI on these systems. The more that an AI system can understand the musical goals of the users, the less parameters that need to be presented to the user, the more that the musicianship of the machine can be actually engaged to try and communicate with the musician at an appropriate semantic level. So that's as we see improved machine learning models, and more will continue, of course, towards that gives a greater complexity of the audio representation. So again, it drives the ability to engage at more complex levels or to understand the music more deeply. One constant challenge is acquiring musical training data, right? So this is bounded by the problems of labeling, and this is a common problem across many machine learning domains with what's called supervised learning. So human annotators require, we require time that is costly to do so. It requires specialized expertise and agreement between annotators that can agree to this. And so, and another challenge is just literally the ontologies of this labeling may differ based on different musical tasks, different musical instrument categories, for example, based on particular requirements. And then fundamentally, there's this question of evaluation. How do we leverage aesthetic judgments of generated music in order to produce a system which we can improve and ultimately meet the commercial needs of this sort of requirement? And so that requires using psychological experimental methodologies for statistical significance or alternative forced choices between models to try and understand what are better producing systems. And finally, also, of course, there's this question of user expectations. Are we trying to, are they evaluating these systems on the basis of meeting the needs of one particular genre or of multiple genres? So how broad versus how deep a system is. And then fundamentally, of course, there's this question of the authorship and the rights management, who owns the ultimately musically produced result. And so that's this question that is ongoing for all electronic art. So finally, just if you're interested to look at some examples, there are some websites there that I can I'm referring you to. So thank you for listening, and thank you.
Hi, hello. Hi, hello. Welcome to Agency and Autonomy. We are moving now into the question and answer portion of this panel presentation. Thank you to our presenters. And just to remind you, we heard from Johnny de Blasi, Iowa State, who spoke about, among other things, 432 hertz. From Carlos Castellanos, who is working on new ontologies of art and artificial intelligence, from Ensun Kang, Carnegie Mellon University, who spoke about several projects, Oral Fauna, Robot Painter, and Zizzo, and from Lee Smith of Lander Audio Inc., who spoke a little bit about Selector and about the challenges of, I think, classification, but maybe we can help us work through that a little bit. From Fabrizio Poltroneri of De Montfort University, who spoke about Amagoi, a really ambitious project that I guess you've been working on this for quite a bit of time, and it's going through now several iterations in development. Okay, thank you for your presentations. They're fascinating, and I think they really work well together and make for a really great panel. We have a couple of questions in the chat. Do any of the panelists have a question for one another before we move to the questions from the audience? Or fine. Okay, so then let me just read, maybe our first question is from Bill Minaris. And Bill asks, from a linguistic perspective, Chomsky, AI techniques, neural networks, genetic algorithms, etc., have a competence and performance. And I think he is just directing this to the panel in general. AI techniques are like hammers and chisels used in classical sculpture. Some artists can use hammers and chisels well. Others can bang away, but only create nonsensical amateur artifacts. What are the thoughts of the panelists on how much knowledge and talent is needed by artists to use these new AI tools well? And how can you tell them apart, talented versus amateur art? In other words, how do you evaluate these artworks that are then produced? Anybody would like to start with this?
I can have a quick go at it and then let other folks dive in. You know, I thought it was an excellent or example to talk about, you know, someone like sculpting, because if you think about a sculptor, of course, they're always interacting with a group of technicians, engineers, artisans to actually ultimately realize a result. And certainly I think that's something that it has been the practice of many people using AI, is to engage with people that are perhaps more on the engineering side, as well as, you know, with people with the aesthetic creative process as their main focus. So it's this combination of these expertise. I sort of see, you know, as the complexity of the medium that we're working with, and now with AI, it sort of demands more community-oriented, generated art, collaborative processes. It's really asking a lot, but I know there's been some great examples on this panel of people doing AI, and I think it's important that people engage with the texture, the material of this. But at the same time, I think there's also this opportunity to say, well, okay, you know, there are people with great skills and a desire to be engaged in the creative process that can collaborate with people, with artists that are thinking far more in the socio-political aesthetic sort of concerns that we see at Isaiah in wonderful ways.
Okay, thanks, Lee. Anyone else have so stressing collaboration in the interface of art and science? Anyone else? And Sun, you've collaborated a lot to produce like oral fauna, those projects. How is your collaborations?
Actually, for the first question, I have a question for the person. What's amateur artwork?
Oh, who would you like to ask? Let's finish this question. I'll come back to you for your question.
Yes, I mean about the the first question we listened to was how difficult. Can you hear me? Yeah, how difficult it is to artwork using AI technologies, right?
Yeah, there's two parts to the question. Mm-hmm. One is the demands on the artist, like the complexity of the tools has really accelerated, and this brings new demands to artists. So I'm paraphrasing here. The second is an evaluative question. Mm-hmm. How can we tell which artists are using these AI tools well and which are producing the, Phil says, talented versus amateur art?
I see. So, hello. Yeah, his school meeting somehow is not happening. It's supposed to
future AI artist.
Right, exactly.
Hi.
So, in terms of
since you've collaborated,
in terms of complexity of using machine learning technologies, there is a really steep learning curve for sure. We all use coding as media artists. However, the level of understanding in Python, we can just use someone else's algorithm if it has all trained model. But the training process itself, if you want to use your own data set, it's already a challenge for the level of knowledge we have. And then if you actually want to develop an algorithm, there's a whole new challenge because deep inside of all these algorithms, it's a mess. Beyond the level that we understand, in my opinion. No, not me. I don't understand. So that's actually the real challenge. And that amateur artists, meaning the people without the professional training, that's my understanding. If that's so, then actually the development of AI technologies can actually assist those people to create pretty complex level of artwork. One of my friend, Debbie, who is a computer scientist, she did this very interesting experiment, creating a software for people to collaborate on for making painting. They are all people without any professional training. So with little bit of help, for example, having different process of working together after this brush stroke, after that brush stroke, and also having a choice portion that people choose which one from the first process they want to work with. There's a second group of people, etc. And the result is really interesting. When people were allowed to just scribble all together, that result was chaotic and in terms of quality, huge spectrum of quality. But when they had certain process to follow up and making a painting together, the result was pretty interesting. The quality was also kind of consistent. That really shows the promise of these technologies assisting people to, in collaboratively or independently, create artwork with less amount of professional training. Well, if I add one more, is it okay?
Yes.
If I add one more, I like to talk about this example of Go. In the Go field, now everyone admits that human champions cannot win against computers, AIs, in Go or chess both. But what happened actually in the field is that people learned these very weird new strategies they haven't thought of from what computers do, what the algorithms do. And people learned that quickly and they started to use it. And I heard
Wait, do you have an example of like some weird strategy that was learned?
I don't know Go that well. But what I heard is Go, you have different ways of moving those stones.
Yes.
And there are these books and video recordings from masters. And people learn it and try to memorize even and use those strategies when they have a game. And what these computers actually tried, these algorithms tried a very unexpected strategy. No masters, no prior masters used, and people, it's like something looking like, oh, that's a bad move, that's going to fail. But actually, the algorithm won eventually, and people learned from it quickly, and they started to use it.
Okay, this is a very fascinating conversation, breaking up a little bit though. So, but Go is a game with an outcome. So I can see art, like to make an artwork is a slightly different situation, right? Fabrizio, is this your hands up? Do you have a comment here on,
Yes.
yeah.
Yes, I think that first of all, this is a very fascinating subject.
Yeah.
You know, I am a mathematician by training, so I think that is very important when Johnny showed in his presentation a piece of code, because you know this piece of code resumes very well what is the kind of state of art in AI nowadays. It's basically linear algebra, matrix multiplications, and operations between metrics. I think that the problem, in my perspective, is first of all, what is the purpose for artists in using AI techniques nowadays? You know, I have been using AI in my artworks for almost 2 decades now, but I have also been a huge critic of these technologies because I think that there is a lack of purpose. And it's very clear for me when I see especially like image generated by guns and all of this stuff that is going on nowadays, and even music. To be honest, 95% of these artworks are just like artists practice using AI is just boring because it's always the same kind of image, always the same kind of music or noises. So what I really think that it's missing, it's a purpose. Why artists want to use AI nowadays? I really support you to the idea that we artists, we need to, you know, engage in these technologies, because otherwise, of course, just big corporations are going to dictate what we are going to do. But at the same time, I feel a complete lack of artist purpose in using these technologies. And I also want to say a little bit about the comparison that the person did about like AIs and the sculpture, or technology and the sculpture. I think that there is a very important point to highlight, and this is that these technologies, artificial intelligence, they are not tools in the sense as a hammer, for example, because these are passive tools. What we are seeing today is not like the use of tools, but the use of apparatus, the use of algorithms, that they are there to prey on us. You know, they are like waiting for actions. They are not passive at all. And I think that most of the artists, they still didn't realize that. So what they do most of the time is to download you know, an algorithm, a new GAN or something from the internet, feed this algorithm with image or sounds, and wait for the results. So this is my question and my critic. Where is the artist's purpose on that? And if I can do some advertisement as well, on Sunday we will have a very good workshop that Ensu is running about
Oh, okay.
about how to measure creativity in using AI, and of course, this is also a correlated discussion. So
Okay.
yeah, so just to wrap it up, I have been, as I said, a huge critic, not of the technology, but the use that artists have been doing of these powerful technologies that we have nowadays.
Okay, Carlos, this is getting into ontological territories, I think.
Well, I think if I could respond to the sort of amateur versus
Yeah,
talented or professional model.
talented. The word would, yeah, talented versus
Yeah,
amateur.
so I think what was really being asked is sort of exactly what Fabrice sort of finished up on there. You know, how do you evaluate good versus bad art in this context? Because in the sense of, I think we're all, I don't really want to speak for everyone, but I think in general, I think we can agree that we as artists are basically amateurs when it comes to machine learning, right? There is a steep learning curve, and you do have to like know some basic stuff, right? Like what latent space is, or what happens when you adjust different hyperparameters or different optimization algorithms. All that stuff you should have sort of a handle on it. But that's not the same as being an expert in machine learning, right? If we use the sculpture model, then a sculptor will also be an amateur. When, let's say, a sculptor uses wood, we don't ask that the sculptor know the molecular structure of wood necessarily, right? Or
it is interesting how profoundly technical many sculptors and painters are, though. I will say.
No, that's exactly right. But it's the sort of domain of knowledge that we expect or ask or artists ask of themselves is more of if we talk about ontological or epistemological model, it's more of a constructivist model. Like they learn and we know from interacting with the material, right? As opposed to the sort of straight up, you have a science experiment, you have a hypothesis, and you test it and measure. They find out from what happens if I heat this at this temperature or that temperature, and then I cool it, or then I add some chemical to it, right? And that's knowledge, right? And then they're applying it in a particular sort of context, right? To ask some kind of social cultural question or get formal, experiment with formal qualities, whatever it is. But they're amateurs in the sense of they don't have the sort of scientific training to know a particular material. I mean, or they might. I mean, and that doesn't hurt certainly. So I think it's more of a question of evaluation of good versus bad art, or how a model decides. I mean, we're working on a project. If I could do a little advertising, Johnny and I are working on a project where we're trying to build a model of beauty, of reinforcement learning agent, deep learning agent that looks at pattern forming bacteria and decides if they're beautiful or not, and tries to change them by actually dropping like chemicals and stuff to shape them into what it thinks is beautiful. Right? And that's a huge question of what we're asking the machine what beauty is. Anything it's going to get from that is an aesthetic measure evaluation that some model that we sort of give it. Right? Because as far as we know, there's no models for non-human notions of beauty. Right? So again, in that sense, we're all amateurs in the best possible sense of the word.
Okay, Johnny, you're an artist. What's your take on this question of like the difficulties of? Did you find it was a steep learning curve to bring AI into your musical practice?
I mean, yeah, I would say, how, it's a good question. How do you evaluate artwork in general? What's good and what's bad, or amateur? I like what Carlos was saying about, how sort of we're all amateurs at a certain level. And it's, in my practice, I was really interested in sort of experimenting and understanding what this is. and how it works. And so, yeah, it is a steep learning curve, but you know, it's kind of what I was mentioning in the talk. It is, you know, simulated creativity now with the in the last few years, and so you know, it's sort of an extension of our computational capabilities. And so, you know, it's kind of like, well, you know, a while back, you know, you use Photoshop filters or whatever, and um, you know, it's an interesting question, but I think it's important to note. You know, my colleagues were mentioning it's you know, a collaboration with the machine, uh, and you know, just like anything else, how do you, like Carlos was mentioning, we're working on that project, and so what is this sort of concept of beauty, and and how can we use AI to sort of understand that?
Okay. All right. Thanks for your answers. I think this is I would encourage people to connect with our panelists in the networking sessions, because I think you can talk about this particular aspect of collaboration with machines at length, and everyone has a slightly different take on it, and everyone has a slightly different sense of what machines, I think, bring to the process. We have another question. We have a few more minutes. We have about 20 minutes left. We have another question, and I'd like to give everybody a chance at it. In an ancillary move, there's a request for Johnny's source code, and I'll encourage that person to connect with Johnny, like through the networking channels. But Thaddeus Mucelli asks, says, we are, and this is directed to all panelists, we are on the path with no return to the process of post-digital societies. Is everyone's perception of this discussion that we should assume a digital ontology as a perspective to understand the autonomy and agency of the machines? Wouldn't this be a moment of transformation while we resist? I say resist acting together with the machines. Okay, so moment of resistance of this kind of like digital ontology. Anyone like to respond to this?
Yeah, let me try and give a concrete sort of scenario of
That would be great.
resistance, because it's interesting, because it sort of creates a dialogue. And I'll give you an example, which is, you know, LaMDA released automated mastering 5 years ago. And it's had an effect of two things. First of all, we got a lot of, you know, mastering is an audio engineering discipline that many people have derived income from. So the natural first reaction to this was, this is going to take all of our work away from us. What very quickly happens is that you start to actually create this, what it did was lower the price point, where people who traditionally would not master their tracks now had the availability of a process driven by AI to do that. So it lowered the price point. What at the same time it did was it actually gave exposure to people. This is the value of mastering. So what, in fact, and we have several, you know, professional mastering engineers working with LaMDA. This has actually driven demand for mastering, human mastering. So this isn't a sort of a replacement. So that resistance, and you know, it's quite legitimate. You know, people are constantly rating how well does, not just us, we're not the only people doing automated mastering now, but how does automated mastering compare to human mastering? So that dialogue of what is the machine doing and what is the human able to bring in this, frankly, this competitive arrangement, or at least can be seen in that way, has actually led to mastering engineers dwelling on their own process and saying, how can I bring more value to the musicians that I work with? And so that becomes much more of a sense of they are experienced people. Typically they are experienced musicians or audio engineers themselves, so they bring a level of education which at this point, technologies like what we do doesn't match. So that idea of resistance is interesting, because obviously that drives us to say, well, those guys are creating value that way. Perhaps there is something that we should pursue. But at the same time, it's also asking creative people to, particularly commercial creative people, to think about their creative process and reevaluate that and sort of reflect on it. And that's why I was sort of also saying, if you look at composers, you know, through the centuries, dwelling on their creative process and using a technology to sort of, you know, as a reflection or as an ability to sort of engage in meta creativity, that this is sort of this process. So the way I see resistance is in the very process of introducing something which is disruptive, and I'm using a capitalist term here, but it also drives that creative process, or at least that reflective process.
Okay, thanks. Yeah. Any other responses? This is an interesting take on resistance as well. I have other questions about music mastering, but maybe I'll get these outside the session. Fabrizio, did you have your hand up there?
Yes, thank you. Well, I think that this is another fascinating topic. I always trying to resist. I would like to say that. But the thing is, you know, my take on that is I'm not really interested, first of all, in machines creating by themselves. I really not interested on this topic. I know that there is a lot of things and a lot of talk nowadays about AGI, human level AI, and singularity. But what is really, really interesting to me, and this is also the topic that I have been researching for almost 10 years, is ways to have meaningful collaboration between AI and humans in a way that the AI challenges us as creative beings, and the AI has embodied, this is also an important topic for me, to have always the AI embodied in the process, in the creative process, and then we can have strategies to refuse, to protest, and to do nice things. But the main thing for me is how we create systems with AI embodied in the creation in a way that these systems challenge us, and we can also challenge the system. And then we will have not only a tool or something that an apparatus or whatever, but then we will have another player. I think that this is also a concept that is very important for me as well. The AI as a player, as something that is inside the creative process and plays an important role in the process. This is my approach, and this is what we are trying to do somehow, and this is what we are researching at the Montfort University in the Creative AI Lab.
Okay, that's interesting. This leads me to a question. We got a new question in from Buratia, and I hope I pronounced that somewhat correctly. What is the degree of autonomy AI and machine learning driven artworks may achieve? How autonomous can that artwork become? Can one imagine works that are alive? Okay, so there's that alive. Can one imagine works that are alive and able to make their own decisions instead of having a dependency on sensory data or cues to provided to them? I'm posing this question keeping in mind the current research and future developments. So, question about autonomy and aliveness, which I think is really a tough question, right? Getting the silence. Unsun, I'm going to you. Like, what do you this? Oh, Carlos has aliveness.
Just very quickly. Yeah, if we talk about, I mean, I imagine the work of Gordon Pask. He was working on like electrochemical. Right. He called them quasi-organic computers. So, you know, the research didn't go very far because this was the age before digital computers. It didn't go very far once sort of digital computers started to take over. But actually, Chaine1 has a good sort of article on Pask's work. So if someone wants a reference to that, I can give it to
Yeah,
them.
no,
But
there's a lot of work being done on chemical computing, biological computing right now.
What I was going to say is right now, maybe if I could just share my screen. Let's give this a shot. Is he going to let me? Yes. I don't know. Can you guys see my screen? Oh, wait. My Mac.
Maybe you might have to paraphrase this for us, Carlos.
Yeah. Anyway, there's people working on like slime mold computers, like Andrew Adamatsky, and there's plant root logic gates. People experimenting with that. You've probably seen like the slime mold that they use to solve the traveling salesman problem, or map like transportation networks. So yes, I mean, it's not a law of nature that computers have to have binary logic or the von Neumann architecture or whatever, right? So as far as aliveness, absolutely, and there's research going on, as you said.
Yeah, and then thanks, Carlos. Yeah, aliveness is like a real hard question for me. Like Ensign, you're nodding. Like oral fauna, like that was like I don't. Do you think it was? What do you think of oral fauna? On this question of aliveness.
Well, it gives
I'm
us
stopping myself before I say something completely nuts.
oral fauna. Yeah, and my name is Unsu. So the oral fauna gives a perception of liveliness, but it's not really alive in the point of biology, right? But like many other artworks, we try to create the experience that gives people the chance of perceiving something that we usually don't. I think that's one of the purposes of artwork, and that's what oral fauna is also trying to do. In general, in terms of AI technologies, we actually need a definition of decision making to talk about autonomy, which is very difficult because, for example, in robotics, even 20 years ago, in robotics, people were teaching robots to, if you go that way, turn right, then turn left. And if there's an obstacle, turn around. And robot does it. And we told it, and then robot moves when it sees an obstacle. By sensing an obstacle, it like turns right or left and go around. Is that a decision making? Then it's happening everywhere in all the algorithms. But if we talk about high intelligence decision making, like we have a desire, we actually wanna collect these ideas and make decision on it, and I wanna express myself. And actually, these decision makings are based on desire that machines don't have. It's purely human desire and human decision making. If we talk about that level, it's not happening for sure, and I don't know if it will happen anytime soon. The level of technical advancement and also the approach we are taking in, for example, machine learning and any other AI methods, it's not any getting close to that direction at all. But in terms of art field, really, I think it's about perception, how we are creating a perception of living things and communication and interaction. And in this sense, many artists are working on it, and some of them are successful, in my opinion.
Okay, great. Fabrizio.
Yeah, I would like just to make a quick comment, especially maybe for the new generation, for the new guys coming to the field, that we had this wonderful researcher, Harold Cohen, that worked for 4 decades intensively in this very subject, that it was the autonomy with Aaron, and he wrote many articles about this process of delegating decisions to the machine or to the system. And I was lucky enough to know him very well and visit him 5 times in Cinitas, and we had a lot of conversation about this topic. And at the end, he said to me, I am the artist, so I am the one in charge of deciding what is good and what is not. But he worked 4 decades. So I think that we can also, take a step back and see also what had been done in the history, not only the history of computers and art, but in the history of art as well. Because if we go back a little bit further, we will see that at the Italian bodegas, when you had a master, this master also delegated to his assistants a lot of decisions. So a lot of artworks that we know nowadays, this is a painting by Rubens, but at the end of the day, like, chances are that Rubens didn't paint at all. It was one of his assistants. So this is the same question. You see the difference of course, we are dealing with another kind of brain nowadays. So I think that this is something that it's also missing in this discussion. To take a step back and see what had been done in the history of art and in history, because otherwise we can repeating, reinventing the wheel instead of making progress.
Yeah, this is a really interesting question if you look at it from the point of view of the artist, of art history, which is in kind of a forever now right now. All forms are like visible at one time. And so artists are in I think, a somewhat different place than scientists and engineers right now with respect to artistic practice. But we have only like 5 or 6 minutes left. But very quickly, one more question. And this kind of leads what Fabrizio was saying, like, how do we look at these in terms of art and perception, and Unsun also the perception of art. Haru Ji asks, I would like to ask about the ontological view on the creative AI technology. I believe that there is more context to this technology than merely the tools. How you are looking is more important because the technology itself will become easier to use. However, our understanding and prejudgment might not. I wonder what your thoughts are about this. So tools becoming easier, this almost brings us to some of the issues I think Lee deals with a lot. The tools becoming easier, but our understanding and our prejudgments are not changing at the same rate.
Yeah, I'll try to keep this relatively short. There's definitely, as you say, that we have. I mean, I'm a musician myself, but I'm not a sound engineer. But we have sound engineers that directly engage with this. So they, in their own process, are thinking about and evolving how they think about mastering. So there's been that process, right? Or thinking about how you're using samples in music. So the very process of engaging with an AI in the creative process, literally building the AI, has created that sort of reflection. So there's that. I want to pick up quickly on what Ensu was sort of saying about that idea of goal or desire or creative impulse. There's this concept of reinforcement learning where you can sort of just give a very general goal and allow the machine to sort of evolve to that. But it still requires sort of some level of selection where if you are, that goal, what is that final goal? Is it a beautiful piece of work? Is it a terrifying piece of work or something like this? There's still that sort of creative goal there. So there's still some level, to me, it's sort of rising up these ontological levels about what is the creative process and where do you engage at it with. And perhaps I'm being optimistic here. I'm sort of saying that as these tools evolve, we have these different levels of engagement that we can, work at. If you want to be coding, that's great. But if you want to be thinking about systems, that's also possible. Or be resistant to these. These are all, to me, legitimate, artistic approaches to.
Okay, great. So we have just a few minutes left, 5 minutes left. Is there anything someone would like to add at this point that I haven't given you a chance to? Yeah, Carlos.
I'll just add really quickly to what Lee said. I think, yes, if we're talking about reinforcement learning that has a goal, that I'd actually say that may or may not actually be quote unquote artistic goal, right? It might actually be about the process of achieving a goal, right? In the context of an artwork, what you want to sort of explore, the status and implications of machines, the fact that they have a goal of trying to figure out if something is beautiful, for example, right? What does that mean, right? So just that's that. One question I did have, maybe getting back more to like the discussion on like perception and stuff, is I guess this is more for Fabricio, but I'm sorry, I forget the name of the project, Amigo, or something, the robots that were trying to be friendly. It strikes me that a slight tweak to that, it could be recontextualized not so much as friendship, but like surveillance, right? Of some kind of if that robot has, let's say, a state apparatus behind it, I mean, you guys heard about those like security robots in San Francisco that people were attacking because they didn't like to be surveilled by robots, right? So I'm just wondering what your sort of sense is of that, and how, I'm sure you thought of it, but what, maybe just talk about it, because context is very important, right?
Yeah, thank you. And you are right. It can become very easily a surveillance apparatus, a surveillance robot, because it's cute, and it's also cute, and people want to interact, and it's very easy to send information, to sell information. Of course, this is not our idea, but this is something that we are aware. And the new iterations of Amigoid, this is something that when we present, we discuss, because people are not, it's crazy how people are not aware of these technologies nowadays. So everybody is buying Alexa's devices and using Siri, and they are basically giving the information for free and making these companies even more multi-billionaires. So I think that this is also my role as an artist, is to use my artworks, in an engaged way, because all of them always have some political side, to explain to people, well, you see, we are using these cute and well-designed devices, but they have this evil side. We are not using your information. We are not collecting your information, but it would be very easy to do that. And then I always give a little bit of technical explanations as well.
Yeah, you've worked on this a lot, responsible use.
Yeah, right. Also related to Haru's question, because it made me think of this ethical question. The last thing I want to say is that people ask these questions: is AI dangerous? Is AI bad? That's really wrong question, because we don't judge the machine itself. My student and I coined this term called machinic surrogacy, and many people here already mentioned that how people make decisions and make these algorithms and how it functions, etc. So what's dangerous is not the AI itself and the people in the system, for the data set and how the data sets are collected, how they are trained, what kind of decisions are made by the developers to use the data set, and what kind of people, like government or company, are going to use in what purpose. So the question is really should be about people making and using them, not really like, is AI dangerous? Is AI bad? That's really completely wrong question in my opinion. That's it.
So from an academic standpoint, that would be sort of technological determinism versus social construction of technology, right? And it's not, obviously there's a continuum there, but that's the question, is how much is the AI just doing its own thing versus how much are people and power systems and all that involved in shaping it. And yeah, I think it's maybe not 100% a social factor, but I think there's a lot of that.
Yeah, I think this is a great conversation. I think y'all touched on this, which is sort of, at the end of the day, there is an intention, there is a goal, and then, also there's a choice on sort of what data sets you're using and who they represent. And I just think it's really great conversation. And I was just kind of thinking about this as, again, before, as a sort of a projection of ourselves. We're really trying to understand what is consciousness, how our brains work. And I think that cognitive science and AI sort of are very intertwined and sort of develop in the same stream for that reason. So yeah, I think it's a great conversation. Thanks.
Okay, so I am getting signals from tech that we are out of time. What a great conversation. I encourage everyone to please connect with our panelists, in the networking chats. So thank you, Unsun, Fabrizio, Johnny, Lee, and Carlos. Thanks for a great session.
Thank
Thank you very
you.
much, guys.
Thank you.
Thanks.